All right, you made it. Final video. So our goal for this video is to um, solve, or actually, sorry, not solve, but to graph the equation y equals 1/4 x squared plus 5 half x plus 21 over 4, not using old school quadratic scenarios or parabola scenarios, but to actually use the analytical geometry's uh, parabola definition or the conic sections definition. So just to recall, notice that the x is being squared. What that tells me right away is that we have a parabola. We wanted to get it in the format of x minus h squared is equal to some constant, that is going to be 4p, times y minus k. That's our end goal, is to make it look like that, and then it'll make it easier for us to graph. So first thing I'm going to do is notice that over here the x has no coefficient on it. So what that tells me is I need to get rid of this 1/4. This 1/4 is just nonsense in the problem. So I'm going to multiply everything by 4. So I'm going to multiply this side by 4, and I'm going to multiply this entire side here by 4. So we're going to multiply both sides of the equation by 4. And the result is going to be 4y is equal to x squared plus 10x plus 21. All right, now remember, our goal is to get x squared. So we need this to be a perfect square. Now, unfortunately, 21, if I try to factor this, 21 is 7 and 3, but 7 and 3 will give me two different binomials, which is not this guy. So what we're going to do is we're going to get rid of this 21 because it's not the right number. So I'm going to subtract it from both sides. So this is going to give us 4y minus 21 is equal to x squared plus 10x. One more time. Why am I subtracting the 21 to the other side? It is the wrong number. 7 and 3 will not give me a perfect square. So what I want to do is I want to complete the square. So I have to think to myself, what two numbers am I adding together to get 10? Well, 7 and 3 did it. The problem is 7 and 3, when multiplied, doesn't give me a perfect square. The only way I can get a perfect square is if I'm multiplying a number by itself. So when I think about 10, I shouldn't be thinking about two different numbers, but in fact two numbers that are exactly the same, 5 and 5. So for me, this number right here, this 10, is actually 5 plus 5 mentally. That way I can think about this number as actually 25. So what I want to do is I want to add 25 to the right side of the problem. I can't just throw it in there, so I'm going to add 25 to the left side of the problem to balance it off. So now we have a new equation. Our equation is now rewritten as 4y plus 4 is equal to x squared plus 10x plus 25. But if I factor that, I get x plus 5 times x plus 5. In other words, x plus 5 squared. Very close to having the equation look like this guy over here. Next, I want to get the y by itself, so I'm going to factor out a 4. Regardless of what this is, I'm going to factor out a 4, and this is going to give me 4 times the quantity y plus 1 is equal to x plus 5 squared. Now for me, I would stop right here and I'd just start graphing, but some of you are like, but it's not in the same format. The x plus 5 squared needs to go in the front. All right, do me a favor, take that x plus 5 squared and just change the order. So we're going to write x plus 5 squared is equal to 4 times y plus 1. And at this stage, you can recognize that our vertex is going to be at -5, comma, -1, and that our 4p is going to equal 4, indicating to us that p is equal to 1. Now since our parabola is going to be opening up or down, and since our p is positive, so now making it open up, so it's either going to open up or down, but because the p was positive, I know it can't be this one, so I'm going to be graphing this parabola right here. So I start by finding my x-axis and my y-axis. So I'll draw my x-axis this way, and I'll draw my y-axis this way. And then I'll plot the points, the important points that I'm going to need throughout this graph. The first one is going to be my vertex. So I'm going to go 5 spaces to the left, 1, 2, 3, 4, 5, 1 space down, and I get my first point, my vertex. And then now I'm going to use the p just to find all the other values. So it's going to be 1, 1 to find the focus. Now remember, this is going to be graphed upwards, so my focus has to be upwards. So I'm going to go up 1 space and put my focus right there. So there's my focus. And then I'm going to go down 1 space, and this is going to give me my directrix. And before I get ahead of myself, I might want to write down that information. So my vertex is at -5, 1. So my focus is 1 above that. So it's going to be at -5, comma, 0. And if you count, it looks like it's at -5, comma, 0. My directrix is going to be at y equals 1 below that, so -2. And if you count 1, 2, it looks like the director is at -2. And then last thing I want to find is my lattice rectum points. So remember, the lattice rectum is 2p, or 2 times 1 spaces from the focus to the right. Put a point right there. To the left, put a point right there. And now, if I wanted to, I can connect those 3 points and extending out my parabola. And I'll write down my lattice rectum points. So my lattice rectum points, if I just want to count it, it's going to be -3, -3, 0, and then -5, 6, 7, -7, 0, which makes sense to the numbers that we have over here. It needed to be 2 spaces to the right of the -5, 0, and 2 spaces to the left of the -5, 0. Thanks for watching. If you have any questions, please hit me up in class.